You're welcome again to our channel, Physics Calculation Center. Today, I told you in our last video, I told you we'll be solving the last question we wrote. So today, we'll be looking at this question critically. It's a past question also. We'll be solving it critically. Okay, let's shoot. So you know in physics, the first thing we do is to write the parameters. So what are the parameters given? If you look at this, we have acceleration. Read the question properly. It says, starting from rest, a Formula 1 car decelerates uniformly at 25 meters per second squared for 30 seconds. What distance does it cover in the last 1 second? And we know that the last 1 second, the last 1 second of motion is the interval between the interval 29th and 30th seconds. And don't forget that the time was basically for 30 seconds. So the last 1 second is from 29th second to 30th second. Okay, so we can now calculate the distance by subtracting. It says it's now calculated by subtracting the distance from 29 seconds and the 30th seconds. So what we do is you say distance equals s, which is, so this is distance in 30th seconds and distance in 29th second. Okay, so we can use our second equation of motion, ut plus half at squared. Ut plus half at squared. Okay, so we use that for this. So let's start with the first one here. The first one here is S30. So let's do for S30 first. So for S30, which is initial velocity is 0, don't forget, is 0. So it gives this half at, and the time is, so it gives it, so let me just put it first so that we can see it. Then that's for S30. So for S29, it will be the same thing, half 80 squared 29. Okay, so we can put this together to become half A into t squared 30 minus t squared 29. Okay, when you subtract this from this, that's what we're saying. Subtract this from this. This is common, the accelerations are common. So the t squared and this will stay. Beautiful. Now we can calculate. So from the question, acceleration is 25 meters per second squared. Acceleration is 25 meters per second squared. And the 2 times I have, which is 30 seconds, and the t29, which is 29 seconds. I got this 29 from the interval because it says in the last 1 second of motion. Okay, so I haven't gotten that. So we can now do substitution. Okay, we can do substitution. I call this equation 1. So substitute in equation 1. So it becomes S equals half. Acceleration is 25 times 25 into, what is the time? The time is 30 seconds, the first interval. And the second interval is 29. The second interval is 29 squared. Okay, so this becomes half times 25, which is 900. 30 times 30 is 900. Minus 29 times 29 is 841. 841. Okay. If you have that, then you have half times 25. 900 minus 841 will give you 59. If you multiply this together and divide it by 2, it gives 737.50 meters. That is the distance in the last 1 second of motion. The distance in the last 1 second of motion. Okay, quickly, let's do the last one. The last one says 17 seconds of the motion. Okay, 17 seconds of the motion. The last 17 seconds. That is 16 before 17. So we do the same thing. We do 16 seconds minus 17 seconds. Sorry, pardon me. We do 17 seconds minus 16 seconds. Okay, so we use the same thing. S equals half times AT squared. Don't forget that the initial velocity from onset was 0. The initial velocity was 0 because it started from rest. Okay, so that's already 0 taken care of. So it becomes half times 25 into 17 squared minus 16 squared. Okay, the same way I did the first one, 17 squared minus that square. So if I do this, I will have half times 25 times 17 times 17 is 289 minus 16 times 16 which is 256. Okay, so this will give me half times 25 which is times 33 which is times 33. If I multiply this with this and divide it by 2, it gives me 412.5 meters. Okay, so from here you would see that to calculate the distance in the last 1 second, all you need to do is to know the equation of motion you are going to use. Once they tell you in the last 1 second, what it means is that the second before the last, so the two of them you subtract it. Once you subtract it, then you're going to get your distance. Same thing applies to 17th second of motion. Do the same thing. Use 16, the 4 second before the 17th, subtract it, you'll get the distance. So these are the two distances that the Formula 1 car covered in the last 1 second and the last 17th second. In our next video, we'll continue with our calculations. Thank you.